The heart-shaped figure shown is given by the equation that we can see here. For x is greater than or equal to 0, so we're just looking at the part that is to the right of the y-axis, this equation becomes this. The curve y equals root x is also drawn. This heart-shaped curve has the special property that for each x-coordinate in its domain, its two y-coordinates are an equal vertical distance from the curve y equals root x. So what we're saying here is that this distance is the same as this distance. And that's going to be important a bit later in this question. Explain why the domain for the curve is given by this. Okay, I'm going to work in this space here rather than the space underneath A, just so we can see the diagram. So what we're saying is that it's from here, from 0, and that this is at root 2. Okay, so let's start with x squared plus y minus root x all squared is equal to 2. Then y minus root x squared is equal to 2 minus x squared. Then y minus root x is equal to the square root of 2 minus x squared. And it would be the positive square root because of the fact that we chose the domain to be x is greater than or equal to 0. Therefore, y is equal to the square root of 2 minus x squared plus root x. Now, this one is fine for greater than or equal to 0. But if we look at this part of the function, for that we need x to be between negative root 2 and root 2. Now, if we combine the two of those, you can see that this domain comes out, because what we don't need to consider is any of the negatives. So the greater than or equal to 0, which we were actually given in the question just here, so we can refer to that as given, and the fact that this one here needs this domain would lead us to this. Okay, so now we're asked to show that the total area enclosed by the heart-shaped figure is given by this expression here. Well, because of the nature of y equals root x, and the fact that we highlighted earlier, so we can see up here, and it was shown on the diagram, we mentioned that this was equal to this. That would mean that the entire heart shape would be 4 times the shaded area. Now, I would mention all of this at the start of my answer to part B. Once you have that, the area is going to be 4 times the shaded area. And how do we work out the shaded area? Well, we know that that is going to be the integral from 0 to root 2 of the upper curve, this part here, and that upper curve, of course, is given by this expression just here. So it's going to be square root 2 minus x squared plus root x. Take away the area under this part, which of course is root x. And then that is just going to be 4 times the integral from 0 to root 2 of the square root of 2 minus x squared dx, because the root x's will just simply cancel. By using the substitution x equals root 2 sine theta, evaluate the total area enclosed by the heart-shaped figure, and hence see why it can be said that pi is at the heart of mathematics. Okay, so we know that area is 4 times the integral from 0 to root 2 of the square root of 2 minus x squared dx. Now, x is equal to root 2 sine theta. That means that dx d theta is root 2 cos theta, and therefore dx is equal to root 2 cos theta d theta. So we have an expression that can replace the dx. Now, the limits on the original integral up here are x limits. If x is equal to 0, that implies that sine theta equals 0, which means that theta equals 0. If x is equal to root 2, that means that sine theta equals 1, which implies that theta is pi by 2. So what we have is that the area is 4 times the integral from 0 to pi by 2 of the square root of 2 take away root 2 sine theta squared, and the dx is replaced by root 2 cos theta d theta. So that's going to be 4 times the integral from 0 to pi by 2. Now, if we think about under the bracket there, that's going to be 2 take away 2 sine squared theta. Since sine squared plus cos squared is 1, that is just going to be 2 cos squared theta under the square root, which means it's root 2 cos theta times root 2 cos theta d theta, which is 4 times the integral from 0 to pi by 4 of 2 cos squared theta d theta. Now we know that cos 2 theta can be written as 2 cos squared theta take away 1, and therefore 2 cos squared theta would be equal to cos 2 theta plus 1. So we have 4 times the integral from 0, and I've somehow gone to pi by 4 here, but of course it was pi by 2 right at the beginning up here. So it's a good job I caught that mistake. And so that is pi by 2. And the 2 cos squared theta is going to be replaced by this. So that's going to be cos 2 theta plus 1 d theta. So that is going to be 4. Integrate cos to sine, so that's sine 2 theta over 2, plus theta to be evaluated from 0 to pi by 2. So that's going to be 4 times sine pi over 2 plus pi by 2, take away sine of 0 over 2 plus 0. Now, this is 0, and all of this is 0. So what we have is 4 times pi by 2, which is equal to 2 pi square units.